All right, so we're back. This is check your understanding number 1, estimating the value of square roots and cube roots. So without a calculator, how do you figure out the square root? Well, let's start with this one. Root of 65. Well, yeah, you know that the closest perfect square would be 64, right? Because the square root of 64 is 8. So if we are going to guess, we're going to estimate, probably a good guess would be about 8.1. All right, 8.2 would be too big because the difference between 64 and 65 is just 1. So maybe just a 0.1 is enough. What about cube root of 80? Cube root of 80, well, look at it this way. The two cube roots that are closest would be 64 and what else? 125, right? The cube root of 64 is 4. Cube root of 125 is 5. Now, what's right in between 64 and 125? Well, you have a difference of 61 about, if you divide it by 2, that's about 30. So right in the middle would be about 94.5, okay? Which probably would give us a cube root of 4.5. And of course, it's just an estimate. Now, where would we find cube root of 80? Now, if you're thinking, so does it mean that since it's somewhere in between here, it's going to be about 4.4? I wouldn't say so because 4.4 would be too close to 4.5 and 80 is not that close to 94.5. Therefore, my guess for cube root of 80 would be about 4.3. Okay, next. More of the same, but this time it involves fractions. So the division property of radicals tell you that there are two things that you can do. If you are getting the root of a fraction, you might want to turn it into the root of the numerator divided by the root of the denominator. Or if you are trying to find the root of a numerator divided by the root of the denominator, you can turn it into just one radical provided that the numerator and the denominator have the same index numbers, meaning the roots that you're getting are the same. Okay, so for example, before I do the examples here, for example, what I can do is cube root of, oops, sorry, cube root of 75 over 100 can be turned into the cube root of 75 over cube root of 100, assuming there is such a number, okay, whatever that is. Okay. Now, if you are starting with something like this, cube root of 75 over square root of 100, you cannot turn it into this. Why is that? They have, oops, sorry, the square root of 100, because this has a square root, this is a cube root, so this doesn't work. All right. Okay, let's go back. What can you do to root of 162 over 50? Well, notice that 162 can be divided by 2. 50 can be divided by 2. Therefore, we can simplify it into 81 over 25. And those two numbers, all right, are perfect squares, right? Okay. So you can turn it into the square root of 1 over the square root of 25, which gives you 9 over 5. There's your answer, okay? What about cube root of 227 over 343? All right, so let's do that. B, cube root of 27 over 343. Well, I don't think we can simplify this. All right. You might think that, wait, the 27 can be divided by 3. That's true. But 343 cannot be divided by 3 just because it ends with a 3. All right. So maybe if we split it up right away, we can get something. What is the cube root of 27? 3. What is the cube root of 343? 7. And there's your answer. So again, I am encouraging you to really be good with your times table, your squares, and cubes because these numbers will come in handy as you can see with these types of questions. Thanks for watching. Bye now.